Hello, my name is Beth Dixon, and I am the Math Lab Coordinator and work in MBSS 222 in the Math and Behavioral Social Science building. And it is my job to help you through your math classes here at Walter State. And today we're going to be studying a short lesson on z-scores for your probability and statistics course. And our first problem, as you can read with me, says the heights of women are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. Beth, by the way, that's me, is 5 feet 10 inches tall, and her friend Connie is 4 feet 11 inches tall. Is Beth or Connie an unusual height? And in this case, this indicates by reading this that Beth or Connie, or really both of us, could be unusual. In this case, am I unusually tall, or is my friend Connie unusually short? So as we start looking at this, we have some pieces of information that we want to be able to pick out. So I'm going to start, I'm going to slide over here and get my sheet of paper. And we want to start with our formula. And so we'll take this problem away. And if you want to keep it in front of you, what you can do is stop the tape and write that problem down. But I'm going to start with just the formula here and the heights of women. And I've got my formula for a z-score, which is x minus the mean over the standard deviation. Now notice on this formula that I'm going to use the symbols for mean and standard deviation that refer to the population, because the heights of women that I'm referring to here is the heights of women as a whole, as the population of women are 63.6 inches. So I'm going to indicate that on my paper. And notice I'm just using a graph here. I don't have to use this, but this is just to kind of illustrate what's going on and to give us a good picture of what's going on. So I'm going to put that in the center here, that the mean of all women have a height of 63.6 inches. And their standard deviation is 2.5 inches. And I'm just writing that somewhere up at the top so that it's there in my site. Notice that the first thing I do is pick out those two pieces of information. Those are the two pieces of information that are important, and I want to pick them out of the problem as I read them. Then as I go back, I notice I'm talking about two different people. I'm talking about Beth and Connie. Well, first of all, let's concentrate on Beth. So I'm going to come down here. And Beth is 5 foot 10 inches tall. Well, our height is in inches. This is in feet and inches. So the first thing I'm going to need to do is to convert that into complete inches. So I'm going to take that 5 feet, multiply by 12, and that gives me 60 inches plus 10 inches gives me 70 inches. And remember that our formula is z equals x minus the mean over the standard deviation. So x is always the score or the data or the particular one that we're talking about. That is the item that's given that we're talking about. So that's, in this case, Beth's height, my height. Mine is the particular one. I want to compare me to the rest of the population. So we always start with that one that's given first. That's what we want to compare to. So I'm going to compare my 70 inches to the 63.6 that's average. And we want to find that difference. How much different am I than the mean? And then we want to divide that by the size of the standard deviations, the size of the jumps, the size of how we divided them up. We said that every group is 2.5 inches. So we're first going to subtract that. And when I subtract bring my calculator here. 70 minus 63.6. That gives me 6.4 inches divided by 2.5 gives me 2.56 standard deviations. And so what that means is that I am 2.5 and a little bit standard deviations above the mean. Now, let's look at Connie's. My friend Connie, and again, notice I'm labeling my information, is 4 foot 11 inches tall. 4 times 12 means that's 48 inches, plus the 11 inches gives me 59. And I use the same, you think you couldn't see that, but that's 48 plus 11 is 59. We use the same exact formula, x minus the mean over the standard deviation. X is 59 this time because that's the number I'm talking about. 59 minus the mean, which is 63.6, divided by 2.5, which is the standard deviation size. 59 minus 63.6 equals negative 4.6 divided by 2.5 equals negative 1.84. Now, my score was a positive z-score because I am taller than the average height. My friend Connie's was a negative z-score because she is shorter than the average height. Now, let's see how that compares back to that curve that I started with. When we do this curve, and the curve we'll learn more about as we go on into some of the later chapters, but what we want to remember is that the mean is in the center of this. That's 0. If we were exactly 63, if I as a woman was exactly 63.6 inches, I would be 0 z-scores, either to the left or the right. I would be exactly in the center. Then the first jump, the first tick mark here would be 1, 2, 3 above the mean, and then -1, -2, -3 below the mean. Now, where do I and my friend Connie fall into the scheme of things? Well, at 2.56, I fall somewhere right here. This is me. If I graphed my place on this number line. Come out just a little bit so you can see the entire left and right at the same time. Then I'm going to graph that negative 1.84 that was Connie's height. Well, that's -1 and almost to 2, but not quite. So Connie's height would be right there. Now, which one of us is closer to the mean? Well, Connie is. She's a little closer to the mean than I am. But let's go back a minute and look and see what the question actually asked. Okay? Is Beth or Connie unusual height? How do we determine unusual? Well, in statistics, we determine unusual as being more than 2 standard deviations away from the mean, either to the plus side or to the minus side, either direction. So as we look at our graph, anything outside of 2 standard deviations is unusual. So I'm going to come down here and I'm going to draw a little box around the 2's. Anything inside of this is usual. And excuse the spelling of usual. Anything outside of that box is unusual. Well, is Connie inside that box or outside that box? Connie's inside that box. So her height is perfectly normal, perfectly usual. Is my height inside that box or outside that box? It's outside that box. So my height is unusual. And if someone was out here on this end, their height would be unusual as well. But we don't have anybody, example for somebody that short. So you'd have to be shorter than 4'11" to be an unusually short person. My friend Connie is not unusually short compared to the average height of women, but I am unusually tall in comparison to women. So that's an example, one example of how you compare things that are alike, both of these, in this case, being the heights of women. And that's an example of how we can use z-scores. Now let's look at another example. And in this example, it's a much longer setup, but actually the problem is not going to be any longer to do. During a recent drought, the production of fruit in my backyard was lower than the average year. Now, actually, I don't have any fruit trees in my yard, so we're pretending a little bit here. I wish to find out whether the apple tree or the orange tree had a worse year for fruit production. My apple tree has been averaging 264 pounds per year with a standard deviation of 88 pounds over the last 10 years. During the same period, my orange tree has yielded an average of 350 pounds of oranges per year with a standard deviation of 25 pounds. During the drought year, my apple tree yielded only 120 pounds of fruit, while my orange tree yielded 300 pounds of fruit. Which tree had a worse year? Well, first of all, I want to see that I've got two different things going on here. I've got apples and oranges. So let's first look at the apples. What's going on with my apples? My apple has an average of 264 pounds per year with a standard deviation of 88, and during the drought produced 120 pounds. Notice how I went through and picked out the information that had to do with the apples. Now I'm going to go back and pick out the information that has to do with the oranges. Well, my orange tree had an average of 350 with a standard deviation of 25 and yielded 300 pounds. Now I'm going to transfer this over to a worksheet. But if you were doing this problem for real, you could just put that information down into two separate little areas to work your problem. I'm going to transfer this over. To my apple tree. So there's my apple tree. And my apple tree had a mean of 264, a standard deviation of 88 pounds. And notice here, I'm using the regular symbols, not Greek symbols, because it indicated that it was a sample of 10 years. And my formula for the Z is going to use these regular letters as opposed to the Greek letters. No difference in the idea here, though, because it's still the data I have minus the mean over the standard deviation. And if you remember from the problem, and if you don't, I'm going to tell you, you're going to for this particular year, during the drought year, my apple tree yielded only 120 pounds of fruit. So that's the data we're talking about. So I want to compare an actual yield of 120 to my average yield of 264. So my z-score x minus x bar over the standard deviation, 120 minus 264 over 88. Now, I've showed you a little bit on the calculator, and let me show you again on the calculator. Notice that when I do this, I hit the enter between it and get that intermediate value, which is the negative 144 in this case, divided by the 88. And we'll stop right here to show you that when we do z-scores, we also want to round our z-scores to 2 places. And in this case, this one is a repeating decimal. And so we're going to go out to the 3rd place, which is a 6. And that'll tell us to take that 3 and round it up. So that'll be negative 1.64 when I round it. If we wanted to do this all in one step, you will need to put parentheses around that top before you hit the divide, and then you could do it all in one step. I tend to do mine in 2 steps because that way I can write down that intermediate value before I do the division. But whichever way that you wish to do it, or wish your teacher shows you how to do it. Okay, but that gives me my z-score now for my apples, which is it's 1.64 z-scores or standard deviations below the mean. So now let's look at our oranges, and going back to our problem, we can come down here to the last part, which says that the orange trees yielded 300 pounds of fruit during the drought year. So in this case, that tells me my x equals, I'll scoot that all the way up so we can see, but my x equals 300. And then again, my formula, z equals x minus the mean over the standard deviation. Again, we're using the mean and standard deviation symbols here for a sample versus before we used them for a population. Now, we're just going to plug in 300 minus 350 over 25, negative 50 over 25, which equals negative 2. Now, we could put the 2 zeros there if we want to have it out to 2 decimal places, but it's not necessary. It's negative 2 no matter which way we look at it. And so now we have the z-score for my oranges. So I've got my oranges and my apples. And how are we going to compare these to decide and answer the main question, which, remember, our main question is, which tree had a worse year? In other words, which one was affected more by the drought? Well, if we kind of go back to our number line, because I'm a very visual, graphic person, and I want to show you that way, we want to know the worst one will not be the one with the highest z-score, but the one with the lowest z-score. If I want to know which one had the best year, I pick the one with the highest z-score. So you've got to be careful that you read your problems. And here's going to be my 0, 1, 2, 3, 1, 2, 3, in the negative direction. The negative 1.64 will graph here. The negative 2 will graph here. So which one had the worst year? Would be my orange tree. Even though it was only 50 pounds off as opposed to my apple tree, it was it was off more standard deviations than my apple tree was. So my worst year was for the orange tree. But again, be careful that you read your problems because your problems will tell you what to look for. But notice on these that you go in, you pick out your information, and you plug them into these z-score formulas. And then you want to look at it. And in this case, both of these were within the 2 standard deviations. This one was exactly on the 2 standard deviations. So this one didn't even have an unusually bad year for my apple tree. This one was borderline unusual because it was exactly on the 2. And most of our teachers won't give you the exact one right on the 2 to determine whether it's unusual or not. Well, and on this one, notice something else. On the first problem, we were able to compare heights to heights, which we can kind of do anyway. But on this problem, we were able to compare our apples to oranges, which we say we could never do, but in this case we did. We compared apples to oranges. And that's the power behind z-scores. We can compare two unrelated things by comparing their z-scores. And so I really tried hard to come up with an example here to kind of emphasize that point and to put a little humor in it as well. I hope this helps you with the z-scores. It doesn't answer all the questions on them, and it's not intended to, and it's definitely not intended to replace your lecture on z-scores because I haven't covered the big idea and what it presents. So be sure that you've gone to your classroom lecture and to remember to get your notes and all from your teacher. And I hope this helps. If you have additional questions, please come by and see us in room 222 MBSS and come and see us for some help. Thank you very much.